Hey everybody, Harold here. The second in my SQLPyR series comparing different functions between SQL's, Python Pandas, and the tidyverse in R. First one was on rank. Uh, Here's my little chart. Kind of holds for all of them. Uh, Ease of use, performance, flexibility, dependencies, and best use case. So if you want to review this, I'll put a copy of it in my uh, on my GitHub. But you can tell most of this is a matter of choice and what you know, unless you're working in a SQL environment, or what you were required to do for your work. So last video, we did the window functions, row number, rank, dense rank, intile, etc. That was the first page in our cheat sheet. So today we're going to do aggregate and value functions. So here's the new cheat sheet, and we'll be covering lead, lag, first and last value, sum, average, max, min, and count, and their variations in SQL, Python, Pandas, and the R tidyverse. So today I wanted to start in R, because that's where I got today's data. So I'm in RStudio. RStudio and R are all free. You can just go download them if you don't have them already. Then we need some packages to do this. If you don't have the packages already, you can just type install that packages in the package name and quote. So you'd put tidyverse and quotes here instead. Run that. Uh, I know I haven't installed, but every time you do a new R session, you have to acquire or library them. So when I get the tidyverse we need for the and dplyr commands, and I'm going to load GT extras because I like the tables it makes for demonstration purposes. So the data set we're using is called Lakers. Comes with the Liberdate package, which is included in the tidyverse. And it is a blow by blow. Let's just show you account of every basket in the 2008 season. And I'm a Laker fan, so I thought I'd use it for this one. So we have, you know, jump ball, Pau Gasol, missed a shot, so on and so forth from first game to the last game of the 2008-2009 NBA season. So let's close that real quick. Uh, I wanted to subset it. I'm a huge Kobe fan, so I want to just get Kobe's data and group it by date, which would give us Kobe's points and a date. So basically, Kobe's points for every game in the 2008-2009 season. So Kobe, Lakers, use the pipe in, select date, player, and points, filter down to Kobe, group by date, summarized by total points. Let's look at the first 6 rows of that. I could say head Kobe. So it's got a date, total points. I don't like that date. Lubridate's got some great functions for dealing with date formats. I'm going to change it to YMD for readability. So I could say Kobe pipe, mutate date, and all you have to do is say YMD. If it's anything resembling a YMD format, it'll turn it into a proper readable format. So let's see the first 6 rows of that. Head Kobe. Now we got a nice looking date. Beautiful, more readable. Uh, Now I'm going to run them all through at once. These are the windows, values, and aggregate functions. Explain them real quick first. Lead points equals lead total points. So that should be the next game. The score total points from the next game. Lag should be total points from the game before. First points, total points from the game First game of the season, last points equals last points. Total points from the last game of the season. Sum points, mean, max, min are aggregate scalar values. The total points he scored, the mean of the points he scored, the most he scored in one game, the least he scored in one game for the whole season. And GP equals N, that's a count. So games played equals N. So you just do all these mutates, lead points, lead total points, so on and so forth. So let's just run that and see what we get. Nice table over here. Total points 23. Lead points 16. That's correct. Lag points is NA. Because there were no points before. First points is 23. That's the first game. Last points is 16. That is the last game. Some points we know from, well, some of his total points for the season was 2,075. Average was 26.2. The most he scored that season was 61. The least he scored that season was 10, and he played 78 games. A couple of things you can do here with the lead and lag. Let's do this on lead. I can say 2. So I don't want to know game points he scored in the next game. I want to know the points that he scored in the game after that. Whoops. Control Z. So when I run that, lead points, it's not 16, it's now 33. Another thing you can do is, if you don't like those NAs, I could say lag points default equals 0 because there was no game then. So let's run that. And now lag points is cleaned up to 0, not that nasty NA. So you could change the how many rows before and after you want to go with the numeric argument there, and you can replace NAs with the default equals argument there. Once I'm done with that, I can write this to CSV, my OneDrive, and then we can take it into Python and SQL. So I'm working in VS Code today, still using a Jupyter notebook. I kind of like to switch around my Python. I use PyCharm, VS Code, plain Jupyter, Colab to get you all used to some different interfaces, different IDEs. So in my Jupyter notebook in VS Code, I need to import pandas as PD. That file we wrote to CSV, I'm going to go get it using the PD read CSV and path to your file. This file will be in my GitHub repository also. Let's take a look at Kobe head. Okay, there's the first 5 games and total points. Got that ugly date format. I use Liberdate and R. I'm just going to do some formatting in Python here. So I'm going to take that date thing and convert it PD to date time, Kobe date. Format equals percent year, percent month, percent day. And let's take a look at that. Much more readable. Very nice. So let's start creating a data frame. I'm going to do in Pandas, there's no lead and lag, it's shift, and then you pick a direction. So a straight shift is a forward shift. This might be confusing, but the lead is a negative. You're not looking forward one, you're moving the value, the next value back one. So you want a minus. So Kobe next points equals Kobe total points dot shift minus 1. And that should give us what we call lead. And let's take a look at that. So next points 16. Perfect. Uh, so if you want to go backwards, you shift 1 the opposite way for prior points. So we'll do Kobe prior points equals Kobe total points dot shift 1. And you could shift 2 or 3 if you want to. You can also, let's do a couple more things here. So you can also say, well, I can move 2 rows and I can, let's see, instead of 1, I could go 2, and something else you can do is fill value to get rid of the NAs. Whoops. If I could spell. So now next points are 0 down here instead of NAN, not a number. Instead of not a number. Keep going though. First points, there's no first and last argument. Basically, you index. So I would Kobe first points equals Kobe total points, index location 0, which is the first row, points in the first row. We'll say Kobe again. So now we got a column of 23s, which we know is the first total points. Again, you index on last, and you can't say, well, I know he played 78 games. I could put ILO 77, but I don't want to do that because the data might be dynamic and changing. So instead of putting ILO 77, you put ILO length of the data frame minus 1. That should give you the last value in the data frame. And it did, 16. Now the aggregates are pretty easy. I can fill an aggregate column. It's scale with a scalar value just by saying dot sum, dot mean, etc. So add the sum as a new column for every row. Kobe sum points equals Kobe total points dot sum. There we go. Recognize that 2075. The mean. Recognize that 26.6. Min and a max. 61 and 10. We know those. And then games played is a count. For that, you use a value count. So Kobe games played equals Kobe total points dot value counts dot sum. So that'll give you basically the count of his games played, or you could have just done something like count rows or shape of the data frame. That would give you the same answer. And one more time to look at Kobe, and that is 78. And now we will move on to SQL. So now here's the SQL portion. In SQL, Windows value functions return a value in a single window, either before or after the current row. So period before, the periods, 2 periods before, the first period, the next period, the last period, etc. Windows aggregate functions allow you to put the scalar value returned by the function in every row. So let me just show you what that means real quick. That may be a little confusing. So I'm going to select star from Kobe. So there's the dates and total points. If I want to get the sum of points, I would say select sum total points. from Kobe and run that. And I get a scalar value, just one number. If I want to put that in a next to regular total points, like this, excuse me for my typos, select total points and sum of total points from Kobe. Well, I can't do that. Column Kobe total points is invalid in the select list because it's not containing either an aggregate function or the group by clause. So you can't put those things together without doing a aggregate function or a group by clause, or so we will use an aggregate function. So I put them all in one statement again here. Select date, total points, lead total points over order by date. So in lead, you have an argument as lead points. Lag total points, same thing over order by date as lag points. First, that should return, lead will return the next game. Lag will return the previous game points. First value should return the points he scored in the first game, and last value should return the points he scored in the last game. Last value is a little different. You have to tell it a range or it messes up. I'll show you that in a minute. Sum, so I'm going to get the column of just the total points. Sum total points over no argument as sum points. Same for average, min, max, and count. So you just put them in there with no argument in the over clause from Kobe. So let me run that whole thing. So total points, lead points 16, lag points 23, 23. First points with 23. We know our last points was 16. We've seen our sum and our average and our max and our min and our games played before. A couple of things you can do in lead and lag. You can uh, go out more than one period. Just put the number in there. So now if I run this, and the same works for lag. So now lead total points isn't 16, it's 33. It's gone 2 games ahead. You'll see these nulls at the bottom of lead. There is no argument for lead and lag to take care of the nulls like there was in R and Python. So you would have to do something like this. So this is a little bit of the difficulty with this, doing this in SQL. You can put a statement like this, put that right under lead. So you have to do something like coalesce lead total points to over order by date and then coalesce it with a 0 as lead points, no null. So when I run that, lead points, no null, now has zeros instead of the nulls. Uh, like I said, SQL lead and lag have no inherent null replacement. A use case. People say, what are you going to do with these aggregates? Well, you can use them as aggregate calculations as subqueries and other calculations. For example, you're asked to find all the nights where Kobe scored more than his average. You could do some subqueries like this. Select date, total points, and then a subquery in your select statement to get average total points from Kobe as average points. All of that from Kobe, where total points is greater than another subquery, select average total points from Kobe. So I want to select date, column with the total points from Kobe, where the total points was greater than average total points, and it's column with the average total points. So I want to select the date, total points he scored, add a column with average total points in each cell, only from Kobe, only where the total points is greater than another subquery, select average total points for Kobe. Then I'll order that by date. So this is just a little more advanced example of what you can do with these aggregates. So let me run that. So now I can say these are the days he scored more than his average and prove it because his average was 26. And all these are more than his average. So that is SQLPyR Windows value and aggregate functions. Here's a little quick look at what we've been over today. Lead, lag, first value, last value, and the aggregates. Sum, average, max, min, and count. Hope you liked this video. Hope you learned something from it. If you did, please like it, subscribe, and I will see you next time. Thanks, everybody.